I'm Richard Costello. You might know me from a suite of Atari ST and Amiga games that I coded back in the day, starting with Gauntlet 2 and ultimately retiring with Primal Rage on the Commodore Amiga. Gauntlet 2 I created in my spare time whilst I worked at Gremlin Graphics on a 1040 ST. And the proceeds from that allowed me to buy something sexy and fast. And ultimately, the Mega 4 was the best that you could get at the time, so that's what I purchased. And then, back then, it was always a case of every time you assembled a large game, it took about 2 or 3 minutes to actually assemble it. And by sticking the fastest machine that I could do for development reasons, it meant it reduced that length of time. And particularly when it's through the middle of the night and you're looking at the screen at 3 o'clock in the morning waiting for it to do something for 3 minutes, the faster the better.
That was the voice there of Richard Costello, an old game developer who recently visited the cave and donated a little bit of history. You can see him here having a chat with Jason at the Dev Den, and that's a video that Jason's put together, the full interview, that will appear on his channel soon. Richard used the machine to develop games such as Mortal Kombat and Primal Rage, the home ports of course, not the arcade versions. And he delivered it to us in the hope that we could bring it back to life and demonstrate to visitors how he used to make games back in the day, the hardware he used, the way he connected it up to the target machines and the software that he used to develop these games. All he could tell us when he delivered it was that it's not working, and hopefully we'll see to that over a couple of episodes. And it also gives me the opportunity to share with you a really cool way of imaging SCSI drives, which I only recently discovered, so I'm looking forward to showing you that. Now, the Atari Mega ST started out life when it was revealed at Comdex in 1986. It was an attempt by Atari to create a more serious machine, one in a desktop case like its more expensive counterparts from Apple and IBM PC compatibles. And I do think the pizza box styling rather than the traditional Atari ST wedge does look right at home alongside the IBM PCs and the Apple offerings. In time, you could purchase this machine with 1, 2 or 4 megabytes of RAM on board. It has a detachable keyboard and an optional hard disk and a monitor that would sit on top to complete the workstation look. Above and beyond the standard Atari ST specs, it also had a blitter socket, which if populated and utilised by software could offer a nice speed bump to graphical operations, and it had an internal expansion port for upgrades, although it doesn't seem like many upgrades came out for it. The Mega ST would arrive in the offices of Popular Computing Weekly in June of 1987, where they gave it a favourable preview with plenty of potential but lamented a noisy fan inside the demo unit. It was, they said, an impressive addition to the ST family. And when paired with a soon-to-be released Atari laser printer, it had the potential to give Apple a real run for their money in the desktop publishing sector. And that's exactly the market that Atari was gunning for, a market with plenty of money sloshing around that they could tap into. This particular one was bought by Richard in 1988. He bought it, as he mentioned earlier, with the proceeds of the Gauntlet 2 port, which he made for the Atari ST and I think for the Amiga as well. And it came with all the bells and whistles, as he'll explain here.
So the hard drive and the Mega ST and the monitor and the keyboard and mouse came together. And then the hypercache was literally halving assembly time. So it was a total no-brainer to stick that in, and it gives you a 16 megahertz, 68,000 rather than an 8 meg, and literally virtually halved assembly time. So what was 2 minutes became 1 minute. Not many other people that I worked with used the Mega ST as a basis of their development system.
No expense then was spared on this machine, and I wonder if it does still have that hypercache upgrade inside. Let's find out.
And before we do, we might be needing the services of PCBWay.com in this series, because their selection of services for PCB design and manufacture, 3D printing, CNC work and lots more besides means they are the ideal partner for retro electronics enthusiasts. Check out the shared projects page on PCBWay.com for easy to order add-ons and upgrades for your favourite vintage computers, and join me in thanking PCBWay.com for supporting projects such as this one.
Just look at this beauty then. This is the cream of the crop. A whopping 4 megabytes of RAM on board and a battery backed up clock, which conveniently uses AA batteries, which are installed at the top back of the case here. There's a bit of juice in there, but there's no signs of corrosion, so that's a good start to this system. Around the back we find all the usual ST ports, a built-in power supply, which of course wasn't standard on the original Atari ST, but in amongst the expected ports there's also this strange red LED and a hole. Now I suspect this is for the CPU upgrade and an optional switch to turn the cache on or off, and either the switch has been lost or it was just never installed, because if Richard used this purely for coding and not for gaming, then maybe he wouldn't have ever been worried about turning it off and he just wanted all of the power all of the time. It's an easy system to get into, and I'm evidently not the first to do so. Then we carefully lift the lid up, and being careful because there's one wire that I need to unplug at the back and I don't want to snap that. And the Mega ST needs all of this metal shielding to keep all of the power in. It's just too much for us to handle without it. With that removed, there it is. It's easily exposed and easy to work on, really. It's quite pleasant. Now I was immediately really pleased to find that the 16 MHz CPU and cache upgrade is still fitted inside. The later Mega ST-E had a 16 MHz CPU which could be switched to 8 or 16 for compatibility, but this, the Mega ST, just had the standard 8 MHz as per the usual Atari ST, unless you upgraded it with something like this. Just above that is the white expansion port that I mentioned earlier for internal upgrades. And we've got 2 ROM chips here with space for up to 6. The ST ROM TOS came in various versions, and well, we have the one that fits on 2. And then we have over here acres of RAM, a quarter of the whole system board just for RAM. Lovely stuff. That's where the bulk of the money was going into when you bought this thing. RAM was not cheap at the time. It's all very tidy in here, and I'm seeing no reason not to test it other than to check the power supply is working first. So let's see that over here. There's no bulging or leaking caps evident on the power supply at first sight, a bit of peeling on a resistor where it's been getting hot or old or both, but nothing of concern. So I'm going to give it a test while it's disconnected from the system board just to make sure it's outputting the right voltages. Our 5 volts is coming out a fraction under, but that should be good enough to test the system with. And the 12 volts, well, that's only reaching 10.7. I tested it with and without the 12 volt case fan connected, and it remained at 10.7. This is okay for testing the board because all of the logic's running on 5 volts. It's the floppy drive that needs 12 volts, but it is a sign that the PSU has degraded, so that needs to go on our list as something we need to sort. Let's plug it into the system board now, and I could see that the 5 volts was making its way around the board into various chips, so that seems good. Let's plug a display in and see what's coming out. And that's not so good. It's a stripy blue and magenta display when we should be booting into TOS and the glorious green desktop that it delivers. Maybe I should take stripy blue and magenta. No, we must fix this thing. So let's do some basic checks first. I stripped it all the way back to a stock 68,000 just in case the upgrade was at fault. That didn't help. I reseated any socketed chips, including the ROMs, and gave some of the sockets a clean just to make sure there was no crust getting in the way of things. Nope, that didn't help either. I checked for any chips that might be excessively hot or have bad joints, so I'm just pressing any chips down, feeling how hot they are with my finger, and applying a bit of pressure as I reset the system to see if any broken joints are rejoined temporarily while I push on them. But no, there are no quick fixes to be had this time, unfortunately, and where would the fun be in that anyway? So let's RTFM, and the service manual from the period suggests that dots and bars on the screen could be RAM, could be the memory controller or video shifters, and it suggests using a diagnostic cartridge to find out. So I've ordered one of those, but let's have a poke around in the RAM area, and fortunately I do have a working ST, this is a Mega ST with 1 mega of RAM, to compare it to, so they're both sat on the desk here. The logic probe shows that the CPU is coming out of reset, and if it wasn't, I'd expect nothing more than a white screen anyway, so something is happening with this machine before it falls over. After a bit of probing around the memory, I can see that these 7.4 series chips are showing some odd behaviour. 2 of them are buffers and 2 of them are latches. Now here's my working Mega ST, in which I can see the 7.4 logic is pulsing away as bits flow and the system works as expected. But on the broken one, I can see that where the address lines were pulsing, something is pulling some of them high. So there does seem to be something going on with the RAM. And after a bit more poking, prodding and probing, I can see that RAM in sockets U44 and U46 specifically had their lines sticking high, while all the other RAM looked to be behaving normally, or as well and as normally as a basic probe can indicate. So my suspicion at this stage is that U44 is the root of the problem, and perhaps the symptom is just carried through to the next RAM chip and onto the latches and the buffers. So on my shopping list goes some sockets, some replacement RAM, and just in case I'll get some of the 7.4 series chips. And between them and a diagnostic cart, we can have a go at trying to fix this. Fingers crossed then that that's going to be the root cause of the hardware problems, and once all those parts arrive, we'll find out. But that's just half the story. The other half is the software, which is on that hard disk. We would need to be able to recreate Richard's development environment and find some of the source code as well if we're going to demonstrate this and show it exactly as it used to run for him back in the early 90s and the late 80s. So let's take a look at the hard disk, which is housed in this case by Third Coast Technologies. Atari did produce their own Megafile hard disk, but there were plenty of third-party options like this one which existed too. The Mega ST supports ACSI, or Atari Computer Systems Interface, which is very similar to the later industry standard SCSI. Inside the case we can see a very chunky power supply, which is encased in a gold cage. The ACSI interface, which appears to have been hot glued into place, and that's since gone brittle and it just flops about inside, which is quite concerning. And there's a filthy fan, which reminded me I should probably put these on. Then there's the hard disk itself. We have a look at this. The label says it's a Seagate branded ST157N, which dates from around early 1988. This drive has a 49 megabyte capacity, 2 kilobytes of cache, and it spins at 3,600 RPM. Or does it? Well, I can tell you that this unit is not in a good way. First of all, the interface had these 4 socketed GALs on them, and when I use a known good power supply to power it up, they are red hot. I mean, hot enough to burn your finger on. Now, a GAL is a generic array logic chip. You can think of it like a very simple CPLD or FPGA chip, which means it's programmed to do a specific job. And with these fried, any hope of bringing them back to life would depend on us having the code to reprogram them, or to program new ones to do the specific function that they're programmed to do, and we don't have that code. So that's a major problem in fixing this particular adapter board. Then there's the power supply. That's given us no output whatsoever on my meter, and it did put out a really bad smell. We could diagnose and fix that, but we'd still have no working interface. But regardless, it's the disk that remains the most important component. So let's see if we can back that up, shall we? And I want to show you this really neat way of backing up SCSI drives because I love it. The first test is, does it spin? So let's put a known good power supply into it. There's a flash of light, but I'm not hearing anything or feeling any vibrations. It's better perhaps than the crunch of our drive head crashing into a platter, but the lack of chuntering is concerning. Nevertheless, let's try and back it up. This is Derek from Flame Lily, my local supplier of the BlueSCSI device, and I'll put a link in the video description where you can find that. And I recently discovered that this device has a feature called Initiator mode. Now in this mode, the PicoPi based device acts as a SCSI host, and it will image whatever it finds on the SCSI bus to an SD card. It's perfect for a job like this, if the disk will play ball, of course.
It slow flashes when it's scanning the bus, and then it'll start fast flashing when it's copying.
Okay.
So it basically automatically starts scanning the bus. If it finds a SCSI drive, it'll just start imaging it to the
right.
Yeah, so
Let's
just
do it.
Okay, so that's slow.
Oh.
The light is on, but it's not spinning, is it?
Desperate times call for desperate measures, and Derek suggested a few judo chops.
modes.
Somebody fetched me a black belt because that did just enough to kick the disc back into life, and the BlueSCSI immediately started grabbing an image of it. We don't know how long this disc will last for when it will fail again, so it really does give us the best chance of getting any data while we still can. The way that BlueSCSI just kicks into life, I was really impressed, and all you've got to do is set a couple of jumpers to run it in this mode. The copy completed, and we had our backup. That is our first goal achieved. I was really pleased with that. And while the Mega ST isn't yet fixed and we can't test that, we can fire up that image now. We just copy the file straight off of the SD card in the BlueSCSI device, and we can fire it up in an emulator and see what happens. Fingers crossed. So this emulator is the Atari emulator, and what I found was the image booted right up. Just straight off the bat, all I had to do was set the emulator into Mega ST mode and give it 4 megs of RAM just to recreate the configuration. But it booted straight up and various hard drive partitions appeared on the desktop. But initial joy faded when I found that only the C partition, which is named Toolbox, had anything in it. All the others were completely empty. There was no sign of game source code. There were some tools in Toolbox that looked like they might be related to development, but there wasn't a huge amount on this hard disk. But I still had some hope because I thought perhaps the last thing Richard did before he switched this off was to simply delete the files and that was it, which would mean the files would still be on the disk there somewhere, marked to be overwritten, but if the sectors hadn't been written to again, we might be able to recover those files. I looked up what recovery tools might be available for the Atari ST, and I eventually settled on a program called Diamond Edge. This allows the restoration of deleted files, but unlike other tools, this allowed me to select directories and restore the directory and all the files within it, rather than the painful process of individual files one at a time. And magically, file names started appearing and I was able to start restoring them. The file system, when you delete a file, simply replaces the first letter of the file with a little bomb icon or character. And that's what tells the OS to hide it and overwrite the space when it needs to. So in restoring the files, I do have to try and guess the first letter of each file, but okay, I'll take that pain if we can get some files back. And what I found was fascinating. I found things like Ramrod. This was a never released Atari ST game which Richard developed for Gremlin Graphics. Here's the title screen which I found on there. And here's what looks like the game completion screen. There you go, you don't need to play through it now, you can see what it looks like when you complete it. And it appears the source code's on there, all the level data. There's even a level editor and browser here, which I was able to skim through a level with. I found sprite sheets and art like this one. And when I asked Richard what this was, this little bald guy, he said this was Napalm Nigel, which never made it past the concept stage. This sprite sheet is really all that ever existed of the game. And even better, it looks like Richard's old tools are on here, including Fungus T Bogeyman's Bogey Dev. And that's the piece of software used to push games out of the Mega ST down the parallel cable and into the target machines. I also found some really interesting correspondence from the period. Letters between Richard and Microprose, Ocean Software and other publishing companies about subjects such as the development of Terminator 2, the game, and insights into testing and the publishing process. Information that I won't share right now without first running it all past Richard for his permission. There's a lot to work through. There are file names to fix when I can figure out the first letter of the file names. But there's so much to be found on here. It really is a treasure trove, and I'm amazed that from a sticky, non-working hard drive, we're able to see all of this. I'm so excited by what we found on here today. I mean, there's an unreleased game on there, which is brilliant, and the development kit software. And well, I asked Richard, have we got everything now that we need to demonstrate this thing?
it would have been DevPack ST is the assembler, and then Tempus was the text editor, and then BogeyDev was the way of getting the result into the machine, and then remote debugging and pausing and going. So there'd be two ends to BogeyDev. There'd be a server effectively, and then a client. And I think the client I will have on floppy disk somewhere, because you just used to put a floppy disk into the ST or Amiga and boot it, and then it'd sit there waiting for you to communicate with the machine. And it's the same cable. So I think it's just a standard handshake lines crossed straight through 8-bit parallel cable. And that connected the two machines together. And then once you've got that in place, you can fire over an image of the game, and then you can literally watch the memory changing on the Mega of your target machine and pause it single step, alter your number of lives dynamically, and see it increase on the screen. You can do all that kind of stuff. So in theory, that's what we should be able to deliver. Yeah, that's the way to do it.
Brilliant. So we can plug an Atari ST or an Amiga 500 into this thing. We can bring up the source code and we can squirt it down. And I've spoken to Richard, and once we've got the RAM or whatever the fault is on this sorted, we've cleaned it up and we've got it all working, he is willing to come down and demonstrate it for us. So I'll make sure that we film that. We can see exactly how it worked. We can get some more information on that unreleased game, Ramrod. Why wasn't it released? What happened to it? Is there an opportunity to release it in the modern day? Is it finished? Lots to find out, lots of secrets still within this, but we're a step closer to finding out about all of them. So I hope you'll join me in part 2 when all the parts arrive and we try to fix this up. And it will really complement the PDS system, which Jason has in the DevDen to demonstrate ZX Spectrum, Commodore 64 and Amstrad CPC. That's what he's primarily demonstrating in there. So the PDS is covering his 8-bit systems. And this can cover the Amiga and the ST 16-bit systems. I'm pretty sure Richard also developed for the Mega Drive on this as well. We'll ask him when he comes down and find out more. So side by side, a couple of really cool period development systems. I can't wait to see this up and running. Thank you, Richard, for dropping it off. Thank you to Derek at Flame Lily. And do go and check out the link to his shop and get yourself a BlueSCSI because they're so brilliant. And I'll see you in the next episode when hopefully we can get this thing working. Thank you for watching. Oh, come and visit, by the way, retrocollective.co.uk if you want to visit the museums, patreon.com/RMC Retro if you want to support what we do and fixing things like this and all of the preservation work that we do. See you in the next episode. Take care. Bye-bye.
I think it'd be great for you to get the system up and running, and it'd be really cool to show people how it used to work. And it's like a really elegant way of doing it. It's straightforward and it's very graphically obvious what's happening. So I think it would be really cool for the cave in general.